Hello and welcome to section 3.7, Inequalities in Two Variables. So today we're going to be looking at graphing inequalities, not like a number line like you've done in the past, but when talking about a linear equation. So this is where we have two variables involved, right? So a couple things to remember. Just like when graphing a single variable, you have an open circle or a closed circle, which depicts if it's an or equal to, or it's just a greater than or less than. It's the same exact idea here as far as there's a difference in them, but here we use a dashed line to represent when we have a greater than or a less than. So dashed line, okay, for greater than or less than. Okay, and we use a solid line, okay, for greater than or equal to or less than or equal to. So that's just to show you, right, if it's a solid line, that means everything on the line is included. So that's an or equal to. And then if it's just greater than or less than, it's the dashed line. Okay, and just like before, when you did single equation ones, right, if you multiplied or divided by a negative number, you had to flip the sign. Well, those rules still apply. So I'm going to write a little note up there about the same thing, right? When we divide or multiply, okay, by a negative, okay, we have to flip the inequality. Alrighty, so then, let's look at our first example here, okay? It says graph 3x minus 2y is less than or equal to 8. Well, the first thing we need to do is solve this for a y equals. Okay, if you were to use this, say, on Desmos, okay, you could go in and you could type that in and it would graph it for you. Okay, but that doesn't really help you out today, right? You need to actually be able to do it, because when it comes time for your test, right, you're going to actually have to be able to do it out on paper. So I'm going to ask that on the homework that you're assigned at the end of this, that you make sure that you do it on paper, but feel free to use Desmos to check and make sure that you've done it correctly. So our first step then is going to be to solve for y. So if we subtract 3x from both sides, this gives us a negative 2y is less than or equal to a negative 3x plus 8. Okay, now I need to get y by itself, so I have to divide everything by a negative 2. When I do that, right, I have to make sure that I flip this because I'm dividing by a negative. So y is greater than or equal to, negative divided by a negative becomes a positive. So 3/2 x, and then we have a positive and a negative, so that's minus 4. Now we have this or equal to, which means we know it's going to be a solid line, right, because the or equal to. So now we need to graph this line. So we treat it though, okay, our original graph, right, when we go to graph it, we're going to treat it as though this is y equals 3x minus 4, right? This is known as the associated equation, which you can see right up here, right? So this is our associated equation. So just like in the past, right, we can use the same principles that we used before to graph these. So I'm going to put a couple points on my graph, and then I'll graph it from there. So my y-intercept is at negative 4, so 1, 2, 3, negative 4. Okay, and then I need one more point on my line. So my slope is 3 over 2, so that means I'm going to go up 3, and I'm going to go over 2. Right, I now have those 2 points, which I can now draw my line through to determine, right, what this looks like. Now, because the fact that it is a solid line, okay, we can just draw the line in and not have to worry about it, because we don't have to make it so it's a dashed line. Now, when you're doing this, make sure you find some sort of straight edge, whether, you know, it be an envelope, or if you have a ruler or whatnot around, any of those things will work. I'm just going to use this envelope right here that's got a very straight edge on it. Okay, and I'm going to draw this, and like I said, it's a solid line, so we can just draw a solid line through here. Okay, and now I have to determine on which side of that line is the statement true. So what I always advise students to do is just pick a point, a nice easy point, to determine if that is a solution or is not a solution to our equation. So if I go back to my equation of y, or my inequality of y is greater than or equal to 3/2 x minus 4. So I'm just going to pick a point. I'm going to put in the point to test. So my test point is going to be 0, 0. So this is 0 greater than or equal to 3/2 times 0 minus 4. Is 0 greater than or equal to, well, that's 0. 0 minus 4 would be minus 4. So you have to ask yourself, is 0 greater than a negative 4? Well, the answer is yes. So I want to shade this in on the side of the line that 0 is on. So I come to the point 0, 0, and that's the side of the line that I want to graph. So all of this, okay, is an answer. Now, if you go on Desmos, right, it'll just put a color all the way up there. Okay, and we'll talk a little bit more about that in a minute. Now, for example 2, okay, here we have 2 of them. So when you have 2 of them and you're trying to solve a system and graph a system, you're looking for the overlap of the 2. So you treat them as 2 separate ones to begin with. So our first one, 2x plus y, is greater than 1. We need to solve for y first, just like on the last problem. So subtract 2x from both sides. We have y is greater than a negative 2x plus 1. I want to point out right away, right, this is not an or equal to, which means this is going to be a dashed line. Now remember, our associated equation to this, right, would be y equals a negative 2x plus 1. So we're going to graph that, but it needs to be a dashed line. So again, we can use the principles that we already know. Okay, we start at a positive 1 for our y-intercept, and then we have a negative 2. So that means we go over 1 and down 2. Okay, so, and if you're someone who likes to have the 3 points, which is totally fine, go right down 2 over 1 again. Again, you get those 3 points. Now remember, right, this is the dashed one. So we get our straight edge out, we get that drawn on here, and now we put a dashed line. Just do the best you can. I mean, if yours are a little closer, a little more spread out than mine, that's okay. But we want to make sure that we put our arrows at the end, right, to indicate that it goes on. So now what we want to do is, again, the same idea. We want to test a point. So if we test, okay, you can pick any point you want. Say we do 0, negative 2. Just pick a point. You just want to pick a point that's not on the line, right? 0, negative 2 is not on our line, so we can use it. So we have to just put that in. Does, except we want it, right, to be in our original. So is 0 greater than a negative 2 times a negative 2 plus 1. So is 0 greater than 4 plus 1? Because, right, a negative 2 times a negative 2 gives us a positive 4. So is 0 greater than 5, right? 0 is not greater than 5, right? This is false. So that means that we cannot fill in that way. Okay, so the side that has 0, 2 on it is not our answer, which means, right, this stuff over here is our answer. So far, that's good. But remember, we're looking at the intersection, so we have to look at our second equation now. X minus y is less than or equal to 3. So if we subtract x from both sides, we get negative y is less than or equal to a negative x plus 3. We then have to multiply or divide. You can do either one by a negative 1. Just we have to get the signs to change. Now, since we divided by this negative 1, we have to flip our sign. Okay, so y has to be greater than or equal to, right, we have negative and negative, so positive. Here we have positive and negative, so minus 3. So now we have that y is greater than or equal to x minus 3. Okay, so then our associated equation would be y equals x minus 3. So then we come down here, 1, 2, 3 for our y-intercept, and then we have a slope of 1. So up 1, over 1, up 1, over 1. Okay, this one is an or equal to, so this is a solid line. Okay, so now I can draw my solid line here. Okay, and now I have to, again, test a point to determine, okay, if this, or what side, right, that I want to fill in. So remember, if you want to test a point, right, you just have to pick a point that doesn't lie on that line. Well, here we could pick 0, 0. It doesn't lie on that line. So does 0 equal, or is 0, sorry, greater than or equal to 0 minus 3? So is 0 greater than or equal to negative 3, right? And this is, yes it is, right? This is a true statement. So that means that we want to highlight above this area. So when we look through this, right, this area from here, this dashed line all the way to this solid line is what we're talking about. And we want to make it very clear that that's what we're looking at. So go ahead and go back in and just darken that up on your drawing when you're doing it by hand, so that way you can very clearly see, okay, that that is the answer. Okay, it's that area on your graph. Now, one of the cool things about this is it doesn't matter how many of these you graph, you can keep graphing them, okay, and you can keep narrowing down areas. So the one on the back that we're going to go over, okay, is actually 3 equations. So we're going to have to graph all 3 of them to determine the area that's enclosed by those 3 lines. Okay, so let's start with our first one, right? We have x is less than 6. So, right, this is less than, which means it's going to be a dashed line. Right, so we know that right away. So we, right, our associated equation, right, is going to be x equals 6. So we graph that, 1, 2, 3, 4, 5, 6. Put a couple points at x equals 6. Okay, when we do that, we can then draw that line, which remember is a dashed line, right? Because of the fact that it's not an or equal to. So again, grab whatever it is you're using for your straight edge and put your dashed line in. Okay, and then you have to just pick any old point you want to determine if it's less than or not, right? So because it's less than, right, and it's just x has to be less than that, I'm hoping that, right, we don't have too much to worry about that, right? Where is x going to be less than that? Well, as we move to the left on our paper, right, those are smaller values of x. So that means that this whole area, right, is going to work for x is less than 6. Okay, then we look at our second graph, okay, or our second equation. X plus y is greater than 4. So if you subtract x from both sides, you get y is greater than a negative x plus 4. Okay, so if we have y is greater than a negative x plus 4, again, we're having this dashed line. Okay, so remember your our equivalent or our associated equation, okay, is going to be y equals a negative x plus 4. So again, we can start at a positive 4. So 1, 2, 3, 4. Okay, and that's our first point. Okay, and then we need to graph a slope of negative 1. So down 1, over 1, down 1, over 1. Right, that gives us 3 points. It's a dashed line. So go ahead and put your straight edge there, and you're going to draw a dashed line. Okay, and then we want to test a point. So if we test into y is greater than negative x plus 4, if we test a point like 0, 0, right, that would be 0 is greater than a negative 0 plus 4. 0 is greater than 4. Is 0 greater than 4? Nope, right, that's false. It's not greater than. So 0, 0 does not work, so it's got to be on the other side. So that means it's got to come up this way. Now, some kids like to use color pencils for these because then it gives them the 3 different colors so they can see more easily where they're intersecting, which if you'd like to do that, that's totally fine. Okay, but then our last one that we now, right, we're not done yet, so we can't just fill that in. We need to look for our last equation. So y is less than negative 1/2 x plus 4. So again, we're talking about a dashed line. Okay, we're at x equals 4, so we want to do our associated equation, right, which would be y equals a negative 1/2 x plus 4. So we go to 4. Okay, but now our slope is negative 1/2. So we're down 2 over 1. Down 2, over 2, down 1. I said that wrong. Over 2, down 1. Over 2, down 1. Okay, so this is, you can see, right, it's a little tricky, okay, when you're drawing this in. So you have to make sure that you're being very careful, okay, when you're drawing these, because it's very easy to make a mistake. And it's kind of hard to figure out where your mistakes are at sometimes because of the fact that you have a lot going on. So just take your time when you're doing this, so that way we don't have, right, the mistake like I just did when I got trying to move too fast. Okay, so now at this point we have this third equation. And so what we need to do at this point is we actually need to, again, test another one. Oh, we didn't draw our line in yet, sorry. So we have to draw in this third line. And again, it's dashed. Okay. And again, we need to test a point that's not on that third line. So again, 0, 0 is an easy one to test. So is 0 less than a negative 1/2 times 0 plus 4? So is 0 less than, that's 0, 4. So is 0 less than 4? Right? My answer is yes. So that means I have to fill out below this. So this is our line right here that we're looking at, and we have to fill in right below this. So now if you look, right, you have to say, okay, well, where do all 3 of these intersect? So I have this area right here that is this dashed line, so right between those 2 dashed lines all the way to my line of x equals 6. Again, make sure that you're being very careful when you're doing this, okay? It's very easy to get these screwed up if you're not paying attention, okay? Now, some of you may say, well, there's got to be an easier way. And I told you guys, right, that we have a program called Desmos that's online that you can use for this. But the thing is with Desmos is that you don't really have to know what you're doing to be able to get an answer, which is why I tell you that you can check your work, okay, using using Desmos, but you still need to know how to actually do the problem yourself. Okay, so what I'll do now is I'll just quickly bring up Desmos, okay, so you can see exactly how this works. So if you just bring up a window and you can just type in here www.desmos.com. Okay, it brings it right up. Internet's a little slow here, so just go to Graphing Calculator. And for instance, the last one that we just did, okay, you can type in the equations. X is less than 6, and it gives you a graph. Notice the dashed line. You can type in the next equation. X plus y is greater than 4. Look at that. I didn't even have to solve for y. So this is an incredibly powerful tool to use, but on your test you won't be allowed to use it. So I have no problem with you using this for just to, make sure your answers are correct, but you have to know how to do it otherwise. So you can see here now, those are the 3 that we just did. That was obviously quite a bit quicker, and you can see right here is that overlap. It's that same exact segment, okay, or group or area, right, that we figured out on our own doing it longhand. So it's there, it's available for you to check your homework on, but I need you to do them by hand. Okay, so each one of these today, your homework, you're going to have to graph them by hand that are like this, and then you're going to take a picture to upload them into Schoology. There are some other ones that aren't these style, but for these ones, make sure you graph them by hand. Now, you might ask, well, what happens if I need to do a greater than or equal to or less than or equal to? So in that situation where you need to do a greater than or equal to or a less than or equal to, like we did at the front page, okay, you just type it in. So say 2x plus y, right, is less than or equal to 3, for instance. You hit the less than key, and then you hit the equals key, and it will automatically put the or equals to there. And then you could type in 3, and it will give you your answer. If you have any questions, just let me know. I hope that you're having a wonderful time with this, and good luck on your homework.